about procedural gaps, them being able to identify the X and Y axis, right?
Yeah.
But when we go into more of a conceptual gap, meaning the thinking behind it, the indirect relationship.
Yeah.
And so when you think about the indirect relationship and that being the highest leverage item, what is something that you can do to increase their understanding of the indirect relationship, or what can you monitor in the process of the lab for them to understand direct and indirect relationships?
I think including a graphing component would be a good visualization of whether or not the relationship is direct or indirect. We can do a little modeling activity with molecular movement and like surface area and temperature.
So when you, I'm sorry.
Go ahead.
You got good?
Yeah.
Okay. So when you think, so just think about the procedural part. Like when we have that graph in front of us, right? We know procedurally we need to show the X and Y axis, right? So that's something we're going to do.
All right.
So what do we need to know about indirect and direct relationships for us to go ahead and get to the next level? So I actually have some thinking steps, right?
Right.
So if we think about the thinking steps of the lab, which part can you reinforce to break the misconceptions of indirect relationships?
Making sure that they understand that on the x-axis, that's our independent variable. On the y-axis, that's our dependent variable. Going over just the general shape of a direct graph and an indirect graph.
So even going back to defining indirect and direct relationships, right? And so going to like, oh, we know procedurally we label the X and Y axis, this is our independent and dependent variable, but how can we tell if it's a direct or indirect relationship? What is the thinking process for me to understand this is our direct relationship and this is an indirect relationship? So when you see a graph, right, do you automatically go to this is an indirect or direct relationship?
No, generally not.
Okay, so now our students generally don't either, right? So what is the thinking steps that we can provide them with to help them get to understanding that this is direct or indirect relationships? What is the in-between?
Okay. Like if I show them a graph.
Or you just take the graph out, right?
Okay.
So you have the Alka lab, right? Something's happening.
Right.
And something's going to happen based on a direct or indirect relationship.
Right.
Right? Something's going to happen based on if I'm changing the amount of concentration, right? Or the item that I'm testing. So how can I then probe my students to say, is this directly affected or indirectly affected? What questions can you ask students?
Okay. I would ask them a question about, before we even start the lab, the 3 sizes of Alka Seltzer that we're using, and make sure they understand the relationship between the size of the Alka Seltzer piece and the surface area of it.
And so, is the Alka Seltzer piece directly affecting or indirectly affecting the results?
It's an indirect relationship.
Okay. You get what I'm going? So if you can then break that down and say, okay, I have this Alka Seltzer piece, right? And so then this is affecting it how? Is it affecting it directly or indirectly, right? And then you break it down from there.
Okay.
And so if you show a direct relationship,
that would be the temperature one.
okay. And so how do I know the temperature is directly affecting the results?
Because as we increase temperature, we increase reaction rate, so they go together.
Yes. So now I'm going to give you 2 minutes to write that down on how to stamp that with students
Okay.
while in the lab, okay?
Okay. So I said for surface area, the stamp that they would need to have is, as we break down the size of the Alka Seltzer tablet, the reaction rate is increasing. This is an indirect relationship. As one of the variables is decreasing the size of the tablet, the other variable is increasing the reaction rate.
Yes. And so this is the trickiest part of the lesson, right? Because we know we want them to be able to get to the rate of change, but they cannot get to the rate of change unless they understand the direct and indirect relationship, and then they will never be able to extrapolate anything from a data table if they don't understand indirect and direct relationship.
Yeah.
So this is the part we're going to go ahead and practice and stamp really hard, okay?
Okay.
So what we're going to do, we're going to get up like in front of the class 100% and stamp this point, and then move them on to the part of them actually taking on the lab themselves, okay?
Okay.
And then I'll be your student. Is that okay?
Yeah. So this would be like an area on the handout
Mm-hmm.
where, like, I would have it up here and everything.
Yep.
Okay.
So my paper should be matching yours.
Okay.
Yep. Do
Okay.
you need your? You probably.
All right. All right, everyone. Voices off. Eyes on me. All right, our first stamp that we're going to do for today's lab is a stamp about surface area. I want everybody's paper to match what I have up here on the TV. Pencils ready. All right. The most important part of the surface area part of the lab today is to understand the indirect relationship between surface area and reaction rate. As surface area decreased when we broke down the Alka Seltzer tablets, our reaction rate increased. So that is an indirect relationship.
And then at this point, you can cold call someone to check for understanding.
Okay.
And so now, can you explain to me what an indirect relationship is from the example that I just given? Cold. Okay. So include that cold call in there.
All right.
So you can then check, and then you'll do another cold call.
That's it. Good class go.
How did you feel about that?
No, this is good.
Okay. And so I'll come in on Monday, right? This is Monday.
Yes, it should be.
Monday, I'll come in on Monday to see you implement that, okay?
Okay.
Thank you so much.
Thank you.